In this video, we are going to use strip diagrams. Strip diagrams are visual models that represent quantities using links. They are especially helpful because they connect arithmetic reasoning to algebraic thinking. Here are a few important tips. Strips represent quantities, just like variables and segments on a number line do. Strips use length, similar to a number line. The same length means the same amount. A longer length means a greater amount. You do not need to make the size comparisons perfect. The goal is to show the relationship clearly. Sometimes it helps to make several drawings to show how a quantity changes over time. Let's look at solving our first problem. The Browns are buying a TV that costs $1,300. After they make 4 equal payments, they still owe $400. How much was each payment? We can draw a strip for the total cost of the TV. This entire strip will represent the $1,300 that the TV cost. Part of the strip that we'll put down here is going to represent the $400 that they still owe. The rest will represent our 4 equal payments. So I'll go ahead and split them into 4 groups that are roughly equal. So this amount of the strip, the 4 equal payments together, are the full strip, $1,300, minus the $400. So $900. Well, we can then take that $900 and divide it into 4 equal groups. When we do, that gives $225. So that tells us that each payment was $225. We could have also solved this using an equation. If I let P be the amount of each payment in dollars, then 4 payments plus the $400 they still owe should be equal to $1,300. We would subtract $400 from both sides. That would give us 4P is equal to 900. Then we would divide both sides by 4, and we would get P is equal to 225. The strip diagram showed us the exact same relationship, and we did the exact same steps. We subtract 1,300 minus 400, and then we divided that result by 4. Now let's try another problem. Altogether, Ron and Dave have 70 toy cars. Dave has 6 more toy cars than Ron. How many toy cars do they each have? Let's let Ron's amount be 1 strip. So we'll go ahead and draw a rectangle there. And then Dave will be the same amount plus a little bit more since Dave has 6 more. I'll go ahead and mark this and let us know that this right here is the 6 extra that Dave has. Together, the 2 strips represent 70. So if we remove the extra 6 from the total, 70 minus 6 is 64. That remaining 64 is split evenly between Ron and Dave, since what we have left are 2 equal matching parts. We can divide 64 by 2 to get 32. So Ron has 32 toy cars, and Dave has 32 plus 6, or 38 toy cars. And we can check. 32 plus 38 is in fact 70. This works. Using algebra, we could let R be the number of toy cars that Ron has. So Ron has R toy cars. And that would mean that Dave has R plus 6 toy cars. That would give us Ron's toy cars plus Dave's toy cars should be equal to 70. This can be simplified to 2R plus 6 equal to 70. I could then subtract 6 from both sides. We would get 2R is equal to 64. And then we divide both sides by 2 to get our answer of R equal to 32. Again, Ron has 32 and Dave has 38. Strip diagrams help us see the structure of a problem before writing or solving equations. They are a bridge between visual reasoning and algebra.